When you're piecing together an aftermarket fuel system, especially for an engine with higher horsepower, a lot of times people focus way too much on the pressure. While that's important, in reality, flow is the number one metric that determines whether your engine makes power safely or doesn't. So I'm going to show you a little demonstration today to show you what different flow looks like at different pressures to give you an idea of what's going on. Well, let's check it out. So for today, we're just going to talk about carbureted engines, but really a lot of this stuff factors over into NA, EFI systems as well. But literally, I want you just to concentrate on carbureted stuff today, because obviously it's what I do the most of. Regular fuel, no E85, no boosted stuff. There's just too many paths this could take us down, and I want this to be a shorter video, not a 4-hour video. So we're just going to concentrate on just a basic carbureted setup and talk through that fuel system setup. So the plan is I want to measure a couple of different pumps, and we've used the test rig that I have set up in the shop right now. We'll wander in just a minute. I'll show you that. But we're going to test out 2 different pumps, and we'll talk about that in detail so you know what we're testing and what the results are going to look like. Pressure gets talked about a lot, and certainly I talk about that, ask that question very frequently when we're trying to determine carburation issues and where you're at within the system so we can get things all running correctly together. But what I want to give you is a couple of different fuel pumps. I can't test a mechanical, or I don't want to test a mechanical. It's just easier to do it on a bench in a controlled situation. So that's what we're going to end up doing. But eventually we may test a mechanical pump. But I want to measure a couple pumps and with their rated gallons per hour. And does it change based on how much flow they're putting out at a specific PSI, including free flow. So we can see how important flow is. Fuel pressure doesn't feed horsepower. Fuel flow does. Without flow, there is no power. So a lot of people think that as long as I got 6 PSI on the gauge, they're good to go, but that number doesn't tell a full story. Before we get into the garage and run through the demonstration, let's just talk really briefly about what we're working with here. Pressure is the push in the system, and it's measured in PSI. How much pressure is in the line, how much pressure the carburetor is seeing in the needle and seats, and how much is being sent to the carburetor, and how much pressure the system is under. So pressure is just that. It's the force in the system. It's how many PSI we're allowing the carburetor to see. Again, it's why a fuel pressure regulator is so important in an analog system that doesn't have a lot of adjustment points. Give yourself the ability to change that and set that pressure so the carburetor sees what you want it to see. But pressure is just the measure of resistance in the system. It doesn't measure the actual delivery of fuel into the carburetor. Best analogy I can give of that is that gauge could, well, that one won't, but that gauge could say 15, 60 PSI, whatever it is. But if there's no flow going through the system, the carburetor doesn't have any fuel and you're out of luck. Doesn't fire the injector, whatever system that you're working on. So you could have 60 PSI on a gauge, but no flow in the system, and what good is that? Now, flow is the important metric here. Measuring gallons per hour, some folks measure it in liters per hour. That's okay, either one. It's how much fuel actually moves to the engine at a given pressure. And that's what we want to look at today, is how much we're actually moving at different PSIs based on, what we set it to, what we set our regulator to. Flow determines whether your fuel system can supply enough fuel to meet the engine's power demands. So if you're making, 340-ish horsepower that this thing does, we have to have a pump and a system that will support that. We've talked quite a bit about fuel system setup in the past, and understanding what the pump is capable of delivering is critical, because if this pump or this setup makes 340, 350-ish, about a 250 liter per hour pump will supply that on an NA, non-boosted, non-E85 application, no problem at all. But if the pump is only putting out 100 liters per hour, you're going to starve the system, and you're certainly not going to make the power you want to make if you're robbing the carburetor of fuel. Now, there are a lot of things that affect flow and pressure. I'm just going to give you a couple right off the top of my head here. The specs of the pump, fuel line size, I'm running -6, a little bit of -8 on the carburetor, but if it was sized too small, it could certainly affect the flow. What type of fuel filters you're running. Temperature is a big one. The hotter it gets, fuel moves a little bit differently. Not enough power going to an electric pump if you've got it. If it's supposed to run on 12 volts, but you're only sending 7 to it, it's not going to give the same amount of flow out of that pump when you're not running as much power to it. Low fuel in the tank would be another one. Incorrect settings on the fuel pressure gauge or the wrong pressure gauge in and of itself. Load, if it's you're under load, it can certainly cause a condition where if the fuel system's not set up, it'll definitely expose those things. So a lot of little things to consider here. I know I'm making it sound a little more complicated than it actually is, but realistically, it is fairly complicated, and to get it wrong, well, you'll know it pretty quickly if you run the engine out of fuel and start hurting things like valves, pistons, whatever. So let's do that. Now that we've got all that kind of out of the way, let's move in the garage. I'll show you the setup because it's been kind of a pain to put together, show you what we're working with and how we're going to test this. All right, we got a lot going on here, but I want to explain to you the system setup and how we're going to run it and what pumps we're going to test. So if you saw the fuel filter video where we measured pressure drop that the pump, or excuse me, that the filters can cause, it's the same basic setup essentially. That is a 160 gallon per hour Edelbrock electric fuel pump, inline pump, gravity fed. So same system as here. I've just got a bucket. We're going to run mineral spirits through it. It's safer than running fuel here in an open garage, and I don't want to cause any issues there, but still flammable, so we have to be a little careful, keep it well ventilated. And we're going to run this just the same way you would a regular fuel system. In this instance, I'm just going to run a single filter. It's all we're doing. Doesn't really matter. In case that filter restricts the flow a little bit, we certainly want to see all that. Pressure regulator, so we can set the pressure and change it as we need to. Down to a gauge so we can monitor the pressure. The big one here is the gauge here to measure the flow in gallons per hour or liters per hour, so we can see that pump is rated for 160 gallons per hour. At 6 psi where we'll start, what does the flow look like that the carburetor is actually seeing downstream? So that's the key piece to it. I'm glad I was able to find that fairly cheaply actually on Amazon to kind of take a look and see what that flow is going to look like. But it'll give us a good indication of what's going on. And then we're going to change that to a much smaller pump to see if a pump that has less liters or gallons per hour in it, when we set it to 6, what is actually delivered on the actual side in flow. So I'm going to learn something here right along with you because I've never run this test before. Certainly we can look at gallon or liters per hour in fuel on an EFI setup because we can measure that at the injector. That's no problem. But certainly on a carbureted setup, I've never done this before. So again, I think it's going to be a cool little exercise to see what that difference is going to be. And then what we'll also do is we will try this at some different pressures, maybe drop the pressure down. I can control the outlet here on this side so I can control some pressure. None of these fittings are tight yet, so I'll tighten all those down in a minute, and then I'll run a hose down into another bucket so we have a full system going through here. So that's the basic setup. That's what we're going to do with the pumps. So let me get this all finished set up, and we'll get that filled with fluid, and we'll start the test. I'm going to show you quickly the setup here so you know what we got going on. Obviously a 12-volt battery hooked up. Underneath there is a relay and the switch, so we can turn it on. There's a switch right there. And we'll just draw gravity fed into the pump through the filter regulator. Watch the pressure regulator on the gauge. We'll measure it through the flow there, down into a bucket, and we're good. Got another camera there, so hopefully I can capture that a little bit, and you can see that. I'll try to put that on screen same time, and we'll try to watch the regulator down there. So that's what it looks like. Again, we're going to do it, I think at 4 and 6 PSI. I may bump that up a little bit and try some different ranges, but if we do, I'll certainly do it. But all right, let me get started. It's going to take me a few minutes to go through all this. The test is going to take nothing. It's changing the pumps out here in a minute. That's going to take a minute, but when we get to that point, I'll show it to you, but I'll kind of show the results and we'll talk about everything at the end. So, all right, here we go. We're all done testing the big pump, and now we're going to test the smaller micro pump, 38 gallons per hour, so it should flow a lot less at pressure. That's what we're going to find out, and yeah, it's going to be interesting. So a little bit of configuration has to happen here on the pumps. That's going to take me a while to configure together, but let me get that set, and then be right back to show you what it looks like. Had to kind of configure this a little bit, but it works. So the Edelbrock micro pump, 38 gallons per hour, all hooked into the system. It works. Now let's test it. One little quick thing about these micro pumps. I know the instructions on the inside or on the back side say it can be used as a lift pump. It cannot be used as a lift pump. Transfer pump, yes, but that pump is designed to work below the fuel level of the fuel. If you look there, where the pump is below the fuel level, fuel is in there, and yeah, it's designed to be gravity fed. It is not a lift pump. So I see that all over the place, and some really popular YouTuber and Motor Trend host loves to use those as a lift pump. They're absolutely not. Eventually that'll come off the instructions. Don't ask me how I know, I just know. So anyway, let's see what that looks like on a 38 gallon per hour pump and at those pressure settings. Let's test it. One thing you can see, that's a complete free flow, and it is just trickling out of there. So I haven't even started really looking at the test. I just want to see what it looked like at free throw or free flow, and it's not flowing a heck of a lot. So should be an indication of what this test is going to look like. So that should drain that bucket that I have up there in, well, a matter of probably 45 seconds. I think it's about out now. Yep. So anyway, not a lot of volume in it. Had to make some changes here, remove their pressure regulator because the pressures were just so low. But take a look at this, at 7 PSI, that thing is just trickling. Matter of fact, the volume is so low, it is barely reading on the gallons per minute gauge. So, all right. Well, let me get all the data on a sheet and we'll talk about it. But yeah, that's pretty pathetic. Let's talk about the results that we got here. So, the 160 gallon per hour pump. Now remember, these are all gallons per minute. So we're going to have to convert this over. I did it on another sheet. But what's interesting to note here is the lower the pressure, the lower the restriction, the more fuel flow. Always going to be the case. Matter of fact, I'll pop up a chart here on the screen. DeechWorks does a really nice job of giving you that information. I don't see this from a lot of pump manufacturers, but knowing what that gallons per hour or liters per minute or liters per hour, sorry, on the DeechWorks graph here will tell you where it falls for the pressure. That would be a very helpful graphic to have if you're trying to pick out a pump. So anyway, unfortunately, none of the manufacturers do that. I think DeechWorks is the only one. So let's take a look at that in gallons per hour. At free flow, wide open throttle, no restriction in the line, 117 gallons per hour. Now, you have to take into consideration you're going through filters, you're going through a regulator. In this case, you're going through, a meter to read the flow and all that. So the more fuel line you have, potentially the more drop you're going to have, whatever. Now, again, this is all Dash 8 stuff that was in this, so it should be pretty free-flowing. You shouldn't have a lot of restriction in it. Anyway, for PSI, 91.2 gallons per hour, 78 gallons per hour at 6, and 64.8. Look at that drop between 7 PSI and 4 PSI. You're losing that much gallons per hour when you're putting that much pressure on there. That's why I say flow is the most important characteristic. If the carburetor needs to be set at 6 PSI, in this case, with that pump, it's only seeing 78 gallons per hour. Now, again, that's probably going to drop down a little bit the more footage you add to the fuel line. If you've got multiple filters, that can certainly take it into consideration. But look at the difference in that in just this really short test bed that we set up. Very, very significant. Now, here's the one that I think is going to be a little, maybe shocking. If you look at the 38 gallon per hour pump, that little tiny micro pump that for whatever reason folks like to use on applications where it just doesn't belong, the interesting thing is that thing's rated at 38 gallons per hour. With that system, choked down a little bit for the 3/8 barb that's in there, but it's supposed to rate it at 38 gallons per hour. It flowed 39 gallons per hour. When you look at 4 PSI, it also hit 39 gallons per hour. Not bad if you're on a lower pressure system. Look what happens when you set it at 6 PSI. That drops down to 12.6 gallons per hour. At 7, it's even worse. It is 4.8 gallons per hour. That's astonishing to me. Now, again, most folks are going to fall into this 6 PSI, at least on a street car. I think a majority of folks are going to be in that. You could call that a universal PSI for most carbureted systems. Some are going to be a little higher, some are going to be a little bit lower. Obviously, the type of carburetor depends on all that, but neither here nor there. Look at the difference if you make that poor choice to have that little micro pump feed your small block, big block, whatever the case may be. That is one of the reasons why people complain about those little micro pumps so much, is because they go, oh, they don't work, it doesn't flow enough fuel. Yeah, it only flows 38 gallons per hour at free flow. Don't try to push it and assume that a 350 horse small block, whatever, like is in the GMC truck, is going to operate at 12.6 gallons per hour. Not enough flow for the pressure that you're providing. So I think that gives you a really, really good indication of why I say that flow is way more important to me than PSI. Sure, that's what we need to set for the system to handle it, to make sure we're not blowing past needle and seats. Everything is working properly in the carburetor. That's the PSI that needs to see the operating. But once we establish that, it's the flow number that I'm really concerned about. And in this case, that 160 gallon per hour pump, no problem. Again, we could test this on the mechanical pump on the truck. I may do that at some point. Just ran out of time, and I don't want this to be a 30-minute video anyway. But I wanted you to see what that difference is, and we took it to two extremes. That's probably one of the bigger Edelbrock gallons per hour pump, and that is certainly, it's not the smallest. They make one for a 1 to 3 PSI system, like for a Stromberg or an old Weber side draft style carburetor or whatever. But for a 4 to 7 PSI rated regulator, you need to be aware of that. So if you're running into fueling issues, if you're running into starvation issues, and you're running that little tiny micro pump, probably got some issues. Now, is 78 gallons per hour what you're going to use on that system? Probably not. If you're using 78 gallons per hour, you are doing something way more aggressive. But it's the flow to keep up with the demand of the system that we're looking at. Having a little bit more flow is way better than having 12.6 gallons per hour of flow going through there. So I hope that gave you some indication of why I say flow is so critical and why it's something you need to consider as you're building out your fuel system. I've got a great big mess to clean up here, so I guess I need to get that started, and then we'll get this video edited and put it up. But if you have any questions on this one, please leave them down below. Again, when we talk about carburetor tuning and issues that people are having, I pretty much ask those same questions over and over and over again. What's the fuel system look like? What's your timing set at? Those supporting systems to a carburetor often are the deal breaker for why you're not being able to get the carburetor to tune the way you want to. So just wanted you to see that, especially with as popular as that little micro pump is. They're not that, well, they're a little bit more money than they used to be. I think they're about $70 now, something like that. I can't remember. That's a little bit older one that I use just here in the garage for transfer and stuff like that. But again, that's very important to understand. If you select the wrong pump based on the flow, you are going to run into some potential issues when you are trying to tune, especially at wide open throttle and even cruise RPM and off idle. All of those things make a big difference. So again, I hope that was eye-opening to you. Certainly was for me. I knew these were going to be kind of low. I didn't know what that number was going to be, but certainly at the max PSI that pump is rated at 7 PSI, that 4.8 is absolutely pathetic. So anyway, leave your questions down below, and if you have any comments on how I ran the test or think I should have done it differently or whatever, leave them down below. But yeah, I think that answered the question of why flow is a more important statistic when we're talking about pumps and systems. So we'll talk to you guys later. We'll see you.